Our project is the Drone Payload Transfer. I'm John.
I'm Nishat.
I'm Prateek.
And I'm Sandesh.
So for this project, what we wanted to do was create an autonomous transfer system between drones that would go ahead and pick up 250 grams of medicine, move it to a midpoint, and then have a second drone find that package, pick it up, and move it to the final destination based on whatever the user wanted to do, wherever it wanted to be.
So we divided our this project into 4 subsystems. I was in charge of navigation and flight control. Nishat was in charge of object detection and obstacle avoidance. Sandesh was in charge of communication UI. John was in charge of transfer mechanism, and precision landing itself was a pretty big task, so we decided to make it a subsystem that we all did.
So my part was the transfer mechanism. Basically, I was responsible for coming up with a mechanism that would enable the drone to pick up the package, successfully, securely carry it, and drop it off. I did this by designing a circuit which will utilize solenoids driven by power MOSFET. I designed a PCB layout for the circuit using Altium, and then I also designed CAD parts of a platform and appendages that will attach to solenoids and be used to latch onto the package. On this slide here, I have a demo circuit breadboard of my design, the PCB layout, and then a 3D model of the finalized PCB. And on this design here, I have the AutoCAD parts. Prateek helped me with designing them. On the top, we have the platform, which would house the PCB, and on the bottom, it would have the solenoids. And the 2 appendages below would be connected together and attached to the solenoid so that it could latch onto the package. I didn't get to design and test my subsystem this semester, but this is how I would validate it based off the distance that the drone is traveling, how high it's traveling, how fast it is, and the weight of the package. And I will use these metrics to determine whether the mechanism passes or fails.
So I worked on package detection as well as obstacle avoidance. And so what I worked on up to date was creating a code that would help detect different colors of packages. I also worked on creating the equivalent ultrasonic sensor circuit that was soldered onto a perf board, which would then be attached onto the drone. I also created 3D mounts that were also attached onto the drone that were connected to the ultrasonic sensors. And then most recently, we worked on the object detection code, and we modified it to allow it to move towards the package. And then all of these were attached onto the drone before the end of spring break. This is a program runtime data. So on average, it took 0.1 seconds for the ultrasonic sensors to communicate with the Raspberry Pi. This is sensor accuracy data, and it basically shows the accuracy of all the sensors from 1, 2, and 3 meters, and it was on average at around 5% error. And then here's the object detection. Basically what it did was find the center of the pink package and tell the drone to move towards it based on a coordinate system grid.
So for my subsystem, I established parameters for flight controllers based on Mission Planner. I also calibrated all the sensors and motors. I established a map link between the flight controller and the Raspberry Pi and attached that to the drone. And I worked with Sandesh more closely and established a connection with his subsystem for long-range communication using the Raspberry Pi and the flight controller. And also with Sandesh, we established a autonomous takeoff and landing using the MAV-linked Raspberry Pi. And with Nishat, we connected the object detection to establish precision landing. And so this is just the MAV-link that we use this is the process of MAV-linking the Raspberry Pi and the flight controller by attaching the pins as shown. And this is just the Raspberry Pi with the communication module integrated with the flight controller.
Yes, I was in charge for the communication, and in 403, user interface was created so that the user can give user can give us the command where they want to pick up the package, and also they can see the location of the drone, and integrated 4G module in Raspberry Pi, and there was the successful data transfer between the user interface and the Raspberry Pi. These are in 403, but in 404, the major achievement was integrating the Raspberry Pi flight controller and the 4G module together. And after that, we successfully made the drone autonomous and tested, and the drone was flying pretty good with accuracy. And the next part was we integrated obstacle avoidance created by Nishat to the drone successfully it integrated. And also I added the code for precise landing to NIST's package detection. And how it works is, after detecting the package and centroid coordinate, Raspberry Pi gives command to flight controller, and the drone move to achieve that centroid in middle of the picture. And this thing is repeated, and actually after that, at the end, a drone reaches the target. And this is the user interface of our project, and where the user can assign latitude and longitude where they want drone to pick up, and left and right box are the location of the one drone, both drone 1 and drone 2. And this is our executive schedule. We are pretty much in time, but we didn't get time to test after integrating.
So for the validation for my transfer mechanism, basically I developed a validation plan for testing the transfer mechanism based off the drone specifications and seeing if the mechanism successfully did what it's supposed to do.
The data previously shown helps to validate the, my object detection, because it shows how accurate these sensors were, as well as how far the camera could detect different colors of the packages.
I created interfaces between the Pi and the flight controller, and using the simulation software, I set parameters based on flight and position.
And for the communication, the data transfer time between the web application and the drone was average 1 second. And the response time of flight controller with Raspberry Pi command was in millisecond. It was very fast.
As for what was left for me to do for project completion, basically to get the PCB and the 3D parts, the CAD parts printed and constructed, and then to implement that system onto the drone and integrate with the other subsystems, and finally test and validate the mechanism and make improvements as needed.
For the object detection, everything was already implemented onto the drone, so all that was needed to do was test in an outside environment. However, we did not get the chance to do that.
For navigation, we just had to match parameters between the two flight controllers, and also attach everything onto a second flight or a second drone, and then test.
And for the communication, we need to assemble next drone and test the proper communication between drone and long-range communication between user interface and the drone. And we didn't get time to test the precise landing, and we need to test the obstacle avoidance too. And the big thing is we need to test the drone in with lots of test cases, so that it won't hit anything, and it's safe for the environment, and the communication won't break in any situation.
In this project, I gained hands-on experience with circuit design and MOSFETs, especially when it came to researching them and finding out which specs I needed for my application. I also learned how to use Altium and do the PCB design.
What I learned was how to use ultrasonic sensors in conjunction with Python. I also learned how to solder onto a perf board. I also learned how to use OpenCV and computer vision to detect objects based on colors. And I also learned about the Raspberry Pi OS as well as the GPIO pins.
I learned how to nav-link between a flight controller and a Raspberry Pi to establish autonomous travel of a drone. I also learned how to use Mission Planner and Cube Coding Controller to establish parameters and how to simulate flight.
And for the communication, working with this project, I learned how to create the web application using the HTML, CSS, and JavaScript, and how to make a server using Node.js Express server. And I learned how to integrate Raspberry Pi, flight controller, and 4G module, and learn how to control Raspberry Pi remotely, and also learn how to create a mapping connection between the Raspberry Pi and flight controller to make the drone autonomous. And I learned the deep learning skills to detect the object and find the centroid using OpenCV library.
And this is just a quick video of our flight, which is autonomous.
Yeah, it says the reach target altitude and landing.
Thank you.
Thank you.